All right. This is a game plan meeting right after lecture on January 22nd, 2020. We have a sprint challenge tomorrow on graphs. So we're just going to go over today's assignments README so that students will be able to know what they need to do and focus on when they come back from lunch. Here we go. Let's have some people hop in here. There we go. We got Luis, Jade, Bryant in the house. Okay. Somebody want to, oh, there's no beta. Does somebody want to pull up the README and we're just going to read through it together and just pick it apart, spend 5 or 10 minutes going over like what it is the game plan is, and so everybody has a really good idea of what they want to do after lunch. It seemed to really help Jade and Tani yesterday. So, anybody wanna? There's Catherine. All right, cool. Thanks, Jade.
You guys see my screen okay?
Mm-hmm.
Okay. Do you want me to go ahead and read it?
Yeah, that'd be perfect. Yep.
Okay.
Thank you.
You have been assigned the task of building a new friend-based social network. In this network, users are able to view their own friends, friends of their friends, friends of their friends' friends, and so on. People connected to you through any number of friendship connections are considered a part of your extended social network. The functionality behind creating users and friendships has been completed already. Your job is to implement a function that shows all the friends in a user's extended social network and chain of friendships that link them. The number of connections between one user and another are called the degrees of separation. Your client is also interested in how the performance will scale as more users join, so she has asked you to implement a feature that creates large numbers of users to the network and assigns them a random distribution of friends. All right, number one, generating users and friendships. It will be easier to build your extended social network, pardon me, if you have users to test it with. There's a populate graph function that takes in a number of users to create and the average number of friends each user should have and creates them. Did I read that correctly? Okay, and then there's an example. Note that in the above example, the average number of friendships is exactly 2, but the actual number of friends per user ranges anywhere from 0 to 4. Hint 1, to create in random friendships, you could create a list with all possible friendship combinations, shuffle the list, then grab the first n elements from the list. You'll need to import random to get shuffle. Hint 2, add friendship with arguments 1 and 2 is the same as add friendship with arguments 2 and 1. You should avoid calling one after the other since it will do nothing but print a warning. You can avoid this by only creating friendships where user 1 is smaller than user 2. Number 2, degrees of separation. Now that you have a graph full of users and friendships, you can crawl through their social graphs. Get all social paths function takes a user ID and returns a dictionary containing every user in that user's extended network, along with the shortest friendship path between each. Note that in this simple users 3, users 3, 4, and 9 are not in users 1's extended social network. And then hint 1, what kind of graph search guarantees you a shortest path? Hint 2, instead of using a set to mark users as visited, you could use a dictionary. Similar to sets, checking if something is in a dictionary runs an O of 1 time. If the visited user is the key, what would the value be? Questions for number 3, to create 100 users with an average of 10 friends each, how many times would you need to call add friendship function? Why? Question 2, if you create 1,000 users with an average of 5 random friends each, what percentage of other users will be in a particular user's extended social network? What is the average degree of separation between a user and those in his or her extended network?
Cool.
Yeah.
That's good, Jay. Thank you. You don't have to read the stretch. Thanks for doing that. So yeah, if we scroll back up to social graph, so what is like the whole premise of this problem? Somebody summarize that real quick. Just a quick little synopsis. Anybody? Mr. Luis Guzman? Goose! Come on, Goose.
I mean, it's multiple stages. So you
Oh, let's
create
go.
the
Sorry, go ahead.
graph and
Mhm.
traverse it, find all the connections.
And then what are we returning?
I think it's what's like a bear with me. I thought it was degrees of separation, but
If you go to the if you go to the top, it says that they want us to return like the friendships. Your job is to implement a function that shows all the friends in a user's extended social network and chain of friendships that link them.
show
Number
all
of connections. Okay. Number of connections. Okay. So it looks like you're gonna return something that looks like an object, I'm assuming, right? And then like that object will have same kind of syntax that will show up when you print like your graphs. And then like you have like the edges that are showing like which what connects to which vertex connects to what vertex. Let me just check to make sure here. And then let's like if we're creating a function for this, do we have any expected inputs or expected outputs, and what are they? Let's go Bryant.
Expected inputs are the user, right? So what user it is. And then that user's friendships. Implement a function that shows friends and users and chain of friendships.
So what do they give you in the actual file? Can you open that up real quick, please?
Is this like, you know, on LinkedIn where it's like, you know, like this person's like a first degree connection,
Yeah. Yep.
second and third.
Yeah, that's a good way to look at it, actually. All right, so let's look at these methods and see what's going on here. So add friendship. So add friendship, you're taking in two parameters, friend ID, user ID. And what would be an example of like a platform that does like bidirectional friendships and one that does unidirect, or I guess.
Bi-directional, isn't that like Facebook automatically? And then Instagram and Twitter, I think, is the unidirectional.
Yeah, because you can follow somebody.
But they don't necessarily follow you.
Populate graph takes in how many? Takes in 2. And in that, you're also going to be utilizing, I believe, the random, maybe not, maybe it's a different function.
Do this so we can see.
So in the populate graph one, you're going to be utilizing the random, which you're going to have to import. All right. Any other questions? Any other things people need clarification with for this one? If you guys are good to go, anybody's okay to leave right now. Like you guys don't have to stay, but I found this really helpful for Jade and for Tani yesterday, and thought maybe everybody could utilize a little bit of extra understanding of a problem before they start it. Any questions? I have the stuff right in front of me right here, so if you want to ask away.
I think I'm still trying to like consume everything I just read, so I don't
In the
have any
reading, yeah.
questions. Yeah, so I don't have
Okay.
any questions so far.
Yeah, there's
Um,
so much.
Yeah, there is
Okay.
a lot.
let's do this. Let's do this because yesterday, it actually happened where Jade and I were the first ones in the meeting, and then Tani came in, and then Jade read it to me first, and then Tani read it to us, and then I read it to them. And the multiple times of reading it, it actually enhanced people's understanding. So maybe let's just read just like that first part again. Maybe Catherine, you want to read this lines 3 through 7.75? What is that? I don't know.
Okay, so you've been assigned the task of building a new friend-based social network. In this network, users are able to view their own friends, friends of their friends, friends of their friends' friends, and so on. People connected to you through any number of friendship connections are considered a part of your extended social network. The functionality behind creating users and friendships has been completed already. Your job is to implement a function that shows all the friends in a user's extended social network, the chain of friendships that link them. The number of connections between one user and another are called the degrees of separation. That would be like the length of the list. Your client is also interested in how the performance will scale as more users join, so she has asked you to implement a feature that creates a large number of users to the network and assigns them a random distribution of friends.
Okay, perfect. Go ahead and stop right there. Let's assess those first 3 paragraphs. Bryant, I thought of you the first paragraph that Catherine read. Like you can see like friends, friends of friends, and friends of friends' friends, which is just like LinkedIn. I thought of that same thing, so thanks for that analogy. What else? Anything else you noticed?
So we're going to have to do a path. So we're going to do a breadth first something, and then do a path from like all possible connections.
Mm-hmm.
Yes.
Yep.
And then the path, the degree from one friend to another would be the length of the path.
Mm-hmm. And the reason why you chose breadth first search would be what?
The shortest.
Yeah, exactly. So yeah, whenever you hear the word shortest in a code challenge, word problem, or anything, just think DFS. Any sort of maze sort of traversal or something, that's going to be DFS. But social networks generally going to be DFS. What else?
This, like, will you input like the number of degrees of separation like you want to go up into? Like, I want to look at up to 5 and then show everyone up to 5 degrees, or is that?
So I think they want you to use those functions that they give you over here on the right of Jade's screen. Like you have, so first you got to create the graph, right? You got the init, then you have the add friendship. And like we talked about, that creates a bi-directional friendship. So you can't, it's not like Twitter or Instagram where you just follow somebody. Like when you're friends with somebody, they are friends with you back automatically. And if you let's see, I think it was later on, like down in the second portion of the README, but it talks about how the number of friendships, right there, line 24. Note that in the above example, the average number of friendships is exactly 2, but the actual number of friends per user ranges anywhere from 0 to 4. Maybe that's not it now. So like the number of friendships it's more than it should be because they're counting a French, like if I'm friends with you, Bryant, like it would count 2 friendships there. Like I'm friends with you, you're friends with me. So you'll have to take that into consideration. It tells you how to import random and all that stuff there. Okay. I'm back up to the original second paragraph, I guess, second or third paragraph. Is everybody all clear on that stuff? Or do you feel like you're absorbing it still?
Okay. Yeah. Okay. So get social pass function will be like for a user ID, return all of this, the social pass, and the degrees.
Yeah, like if you scroll down on the right side there, Jade, in your social.py, yeah, what other functions do we have there? We have populate graph. We have get all social paths right there, Brian, where it'll take in user ID and it'll return all of that person's, I guess, a dictionary. Yeah, dictionary containing every user in that user extended network with the shortest friendship path between them. So just like Catherine said earlier, like that should measure the distance between you and that friend. So like between you and Kevin Bacon, it'd be 6, right? Like between us, it'd be 1.
So you're going to want to loop through all of the users and then do a breadth first search between your user ID and those user IDs, and then return those paths.
Mm-hmm.
And then this friendship thing, self.friendship, is kind of like an adjacency list.
Is that what it says there?
Well, that's what it
Yeah,
looks like when
yeah,
it out.
it will, yeah. Yep, that's correct. Let me look at that for you here for populate, forget all social paths. Yeah, so get all social paths will be very, very similar to like what you guys are used to doing with BFS and DFS. It'll look very similar to that. Populate graph. Okay. All right. Does that help clarify some stuff for you guys? For that one that you guys will be using, like the user ID, you know, it says create a new user with a sequential integer ID on line. If you scroll down up a little bit, I think. Okay, last ID. Okay, you guys have that. Okay.
But add user takes in a name.
Mm-hmm. Yep.
But where is, so name, let's take self.name.
Mm-hmm.
But what's name coming from?
I think that's what you would just be passing into the add user
Oh,
Yeah,
there's
method.
Yeah, it's coming from the
Yeah.
user method.
Okay.
Oh.
Where did it come from?
Yeah, hidden class up there at the top. Yeah. Anything else that might look confusing? Notice the warnings, you can't be friends with yourself. Friendship already exists.
So that's just like adding edges.
Mm-hmm. Correct. So interesting thing to think about here. So I think yesterday they talked about the difference between a dictionary and a set, right? Like a dictionary would be considered an ordered collection of data. And so like it was useful yesterday because you could add things to it and it wouldn't take any duplicates, right? So like here, do you want to use a dictionary or a set?
It says dictionary.
It says, yeah, dictionary instead of a set. Or it said instead of, you could use a dictionary.
Right, I mean,
Well, they wrote
yeah.
it as a dictionary under get all social paths.
Under,
They said visited. Yeah, visited
Okay.
is a dictionary.
Okay, any other questions that you guys guys want to clarify? So actually, sets are also written with curly brackets too in Python.
I was
So just-
actually going to ask about that because
Yeah.
during Brady's demonstration or his video, he showed that the sets were in brackets. So I was wondering if they are one and the same.
I
Or
think a set is just like a hash table with just
Mhm.
keys and no values.
Mhm.
okay, okay,
Yep. It says you cannot access items in a set by referring to an index. Since sets are unordered, the items have no index. But you can loop through the set items using a for loop, or ask if a specified value is present in a set by using the in keyword. So you can loop through the set, and you can also check to see if there's a value that's in there, because like Catherine said, those are the keys. There's like a dictionary with just the keys.
thank you.
Wait, were you
So
reading
it's-
something just now?
Friendships. Sorry,
What's that?
Tony.
Where, that's okay. Tico, were you
Yeah.
just reading like the definition?
Yeah, do you guys want me to drop that for you?
Would you mind? Just so, I mean,
problem.
I could do it later, but it'll
Yeah,
save me like a minute.
No problem. Let me drop that here.
So friendships is like line 36 and 7 on the left. Like it's so it's the like is that a set? Like 1 colon line 37.
Yep.
Yeah,
Mhm.
this is
And
the
five.
user ID, and then these are the. Please correct me, somebody. Are these the friendships,
Yeah, the
IDs?
connections.
the
Yeah,
connections?
Mhm.
yeah. So it's
Yeah.
just like an adjacency list.
Yeah.
You have vertices and then like which vertices are they connected to. But we're
Mhm.
just calling them friends and friendships or whatever.
Yep.
And then connections. There's a list. That's the path.
Mhm. So how would you interpret line 43? Can somebody interpret line 43?
Well, one has no friends. It's by itself.
Mm-hmm.
um,
You can't be friends with yourself, right? You can't be friends with yourself. Okay.
8 is connected to 1. Well,
Mhm.
why is 1 only connected to? It's
Maybe because 1 was added first.
One is
So
the
there was no
original.
one there yet.
Yeah,
Oh,
one is the
smart.
original user.
Smart. Yeah.
Good
Okay.
looking
So,
out, Tony.
That's Tom. Tom from,
Oh,
MySpace.
yeah.
so 8 is friends with 1. 10 is also friends with 1. 5 is friends
Yeah.
with 1. 2 is friends with 1 and 10. 6
Mhm.
is friends with 1 and 10.
Mhm.
Why are they all in these? Their own numbers are included in their connections. So then the number of connections would have to be the array minus 1 because you can't
Correct.
self.
Correct.
Oh. Okay.
Correct. So let's see. So notice like, yeah, so in the sets on line 40, like user 1, right? They're friends with, that's the comprehensive list of friends. And then if you look at like on line 43, you have, let's see, or line 8, sorry, so 8 right there on line 43 is friends with 1. And then you have 5 and 3 that one is also friends with, or 5 and 10, right? So you go to 5, you have 1 in there, and you have, if you go to 10.
Wait, I'm confused though because 5 is also friends with 8. So 8 should have 1, 8, and 5.
Is it because you have this user who has all these friends first, and then you have a
Mhm.
second user, and say 2 and 1 become friends, so then 2 automatically inherits 8, all of user 1's friends? Is that what it is? Because we're looking at double connections? Or did I just make that more confusing?
I think it looks like compared, based off what they have, like on line 40 and then on line 43, I would think that there were other paths.
Let me see. Do.
So 40 is printing our paths and 43 prints our connections?
40 prints are friendships, right?
Yeah.
Okay.
And then would the paths be here? Is that what we're saying? Like,
But they
Well,
want
it says print connections on 42 though.
but they want all the social connections to 1.
to 1.
Oh, yep.
That's why.
That's why 1 is first. Okay. So then actually, like, that should give you the path then, right, to that friend. So like the first item in that set, like you're friends with yourself, right? So that'd be like 0 degrees, right? And then 8, you're friends with the 8 guy. So that
is
goes
a
from 1
path,
to 8,
okay.
right? And then like look at like number 2 over there. So that means that there's 2 degrees of separation between you and number 2 guy, right?
Yeah. Oh.
Does that make sense?
Yeah, now that makes more sense. Yeah.
So yeah, it is a path. You're right, Jade.
Very good, very good. Yeah. So this guy right here, how is he friends with this person?
Through
Number
10.
1. Yep. So yeah, through 1. So yeah, so you got 1 and 2 degrees of separation right there.
So it's always
Gotcha.
the length of the path minus 1 will be the number of degrees.
Mm-hmm.
And also the number of friendships?
Well, if you look
Or
up
no?
here, this would be like the total number of friends. So like
Okay, gotcha.
yeah, so like person 1 has like 3
3
friends. Yeah.
Okay.
Because if you notice, there's no like it doesn't include like their own user
Gotcha.
ID in there. So
Okay, so that's a
Okay.
breadth first search. It's going to intake a user ID, and then you're going to iterate over this friendships adjacency list.
Mm-hmm.
And then for each vertex in the adjacency list, you're going to do, yeah. Okay. But then in the get social path, it only intakes self and user ID. But
Mm-hmm.
you're gonna also want to need the list of the friendships thing. So how do you, because it's self, you can access self dot inside, right?
Mm-hmm.
Okay, so I can access self
Yeah,
dot friendship.
here it is right there.
Oh,
Yep.
amazing.
Yeah.
Okay.
And then
wait.
notice over here too, I mean, they're creating a variable called connections that allows you to, use that get all social path method on top of the SG or social graph. Just right here.
Okay. So I have access to those things. Okay, perfect.
Mm-hmm. Cool. So everything makes sense? Everybody feel like they have a good grasp of what they'll be working on after lunch?
That
Yeah.
helped.
Yeah, that helped a lot.
Good.
Thank you.
Good. Yeah, thanks for everybody's input. Like everything, I feel like everything just comes together in one of these kind of meetings because everybody's perspective is so valuable. Like Bryant saying like it was LinkedIn, it just creates a mental model in my head that I can work off of now, So it's good. All right. That's all then. Go get some lunch, get some R&R, and then hit it hard when you get back.
Bye, guys.
Cool. Thank
Bye.
you.
I'll
Thank
drop
you.
this video on the channel. Yep. See you guys.